in this video we are going to solve some questions on kinematic equations to compare quantities. In this first question, car A starts from rest, covers a distance x and reaches a speed of v, while car B also starts from rest, covers double the distance covered by car A and reaches double the speed of car A. Acceleration of car A is A. What will be the acceleration of car B? So when we have such a comparison problem, it's easy to put it in a table and then look for the equation which will help us. Okay, so I'm going to make a table here. Let's write car A and car B. Then we know what's the initial velocity. Then they also are talking about the distance which is covered, that is delta x. They also said about the final velocity, and there is some information given about the acceleration. So initial velocity for car A is 0 because it starts from rest, so car A is at rest. Car B also starts from rest, so car B also the initial velocity is 0. The distance covered by car A is x, so I'll write that. The distance covered by car B, it's double the distance covered by car A. So if car A is x, car B will be 2x. The final distance or the final velocity of car A is v. And for car B, it is said that it reaches double the speed of car A. So we'll write that as 2v. Acceleration of car A is given by the letter A itself, and we want to find what's the acceleration for car B. So now if we look at these terms here, Vi, delta x, Vf and A. So we want to check for a kinematic equation which will have all these terms coming together. So we'll write Vf square equal Vi square plus 2A delta x. That's the equation which we can use here, because we can see that there is Vi, Vf, acceleration and delta x. All of them are involved. Now we can also see that both the cars are starting from rest. So this will become equal to 0. So we'll have Vf square equal 2A delta x. Now again we'll look at the table. We can see that they have information about delta x in the problem, as well as there is information about Vf in the problem, and we want to find what's the acceleration. So what we are going to do is we are going to rewrite this equation in terms of acceleration. Acceleration will be Vf square over 2 delta x. And then we can write acceleration of car A over acceleration of car B equal Vf square, that is Vfa for car A over 2 delta x for car A. So I'm just going to write for car A first, then we need to divide. We can see that there is a division here. So we'll put divide Vfb over 2 delta xb. Okay, this we can further write as Vfa square over 2 delta xa. Then division I'll change to multiplication. This will become 2 delta xb over Vfb square. And then we can cancel out whatever is common. So 2 can be cancelled out. And the rest of it, I'm going to look at the table and replace these expressions with the help of the table. So let's do that here. We'll write AA over AB is equal to VFA. VFA is V, so we'll write that V over V square, okay, because there's a square. Delta XA, we can see delta XA is X, so we'll replace that by X. Then multiply. Delta XB is 2X, so we can write that as 2X over VFB, VFB is 2V. So we'll write that as 2V and then whole square. So we can again cancel out what's common. We can see x is common. We can cancel that out. And V square multiplied by 2 over 2V square. So that will become 4V square. And we can cancel out the V squares. V squares can be cancelled out, and 2 over 4 will give us 1 over 2. So AA over AB is 1 over 2. That means AB, that is acceleration of B, is 2 times acceleration of A. I just cross multiplied it like this. So I can write acceleration of B is 2 times A, because we said acceleration of A is represented by A. So that's how we can complete this problem. Okay, let's look at another problem on kinematic equations. Object A initially at rest accelerates to reach velocity V after covering distance D. Another object B with triple the acceleration of object A, starting from rest, moving on the same surface as object A, reaches the same velocity as object A. What will be the distance covered by object B? So again, it's a comparison question, so we'll draw a table here. So object A and object B. Let's write the VI, then delta x, VF, and acceleration. Okay, so let me just make some space here so that we can see them clearly. VI, VF, delta x, and acceleration. Okay. Object A initially at rest. So object A is at rest, accelerates to a velocity V after covering distance D. So it reaches to a final velocity V after covering distance D. Another object B with triple the acceleration of A. That means if I take this as A, this is triple, so 3 times A. Starting from rest, so B is also starting from rest, and moving on the same surface as object A, reaches the same velocity. That means its final velocity is same, and we want to find what will be the distance covered by object B. So as we did in the previous question, we will look at these terms, VI, VF, delta x, and A, and choose a kinematic equation which fits in the situation. So here also, VF square equal VI square plus 2A delta x fits in, because all the terms can be seen in this equation. Now VI is 0, that means I can cancel this out. I'll get VF square equal 2A delta x. We can see there are 2 things which are constant here. We can see that velocity is constant. No, only one thing is constant, that is velocity is constant. So final velocity is constant. Okay, so I can rearrange this equation as acceleration. Instead of acceleration, let me rearrange the equation for delta x, because that's what we are trying to find. So delta x is equal to VF square over 2A. Now, because VF square is a constant, 2 is also a constant, we can see that delta x is inversely proportional to acceleration. Yes, we can see that delta x is inversely proportional to acceleration. So that means if I want to find delta x A over delta x B, I can get this equation. So delta x is inversely proportional to its acceleration. So I'll write AA here and I'll write AB here. So what I'm doing is I'm using this inverse proportionality to create this equation. You can see that delta XA is inversely proportional to AA and delta XB is inversely proportional to AB. Now we already know some information about AA and AB, so we can write down that. AB is 3A, so we'll write 3A here, and AA is A, so we can write A here, and they get cancelled out. So I can see delta XB will be 1 over 3 delta XA. So I'm just rearranging this equation and I can get the relation between the two. Okay, so delta XA is represented by D. So we can write here, I'll write here on the top, delta XB will be D over 3.